The 19th century expansion of the British Railway in India is frequently cited as a triumph of colonial infrastructure. In practice, the physical construction of these tracks operated as an engine of immense unintended destruction. The logistical crisis began in the 1850s. British engineers were ordered to lay down the Punjab Railway, a critical commercial route connecting the cities of Lahore and Multan. This topographical map of the Indian subcontinent highlights the Punjab region, and it immediately reveals a geographic constraint. The path from Lahore to Multan sits entirely on soft alluvial soil. It is a vast plain, completely devoid of mountains, stone quarries, or hard rock. Transporting massive quantities of hard stone from hundreds of miles away to this flat region was economically prohibitive. The engineers faced a severe material deficit, halting their progress. This specific resource bottleneck in the Punjab plains forced a choice that would determine the fate of millions of tons of buried history. Desperate for a solution, the contractors were directed by local villagers to a series of mysterious nearby mounds. These hills, the locals explained, contained a seemingly infinite supply of incredibly hard, perfectly baked bricks. These mounds were the ruins of Harappa, a sprawling metropolis of the Indus Valley Civilization that had thrived around 2600 BC. To bypass their infrastructure bottleneck, British engineers authorized the systematic mining and pulverization of millions of these highly engineered ancient bricks. The engineering qualities of the Harappan world provided the exact material solution the British were looking for. This photograph shows the mechanical drive shafts of an early passenger locomotive. A steam engine moving over steel rails generates immense downward physical force and violent kinetic energy. That energy transfers directly from the heavy iron wheels, down through the steel rails, and into the horizontal wooden sleepers positioned beneath them. This 3D cross-section shows the failure state. Tracks laid on soft mud sink as transferred energy destabilizes the sleepers. To prevent this, engineers install ballast. Crushed stone packed beneath the sleepers interlocks, absorbing vibration, distributing force, and allowing drainage. Without a massive local supply of hard matter to crush into ballast, the entire Lahore-Multan railway project would physically fail. The strict physical requirements of 19th century locomotion created an insatiable demand for dense matter, setting the exact parameters for the extraction at Harappa. Moving the timeline backward 45 centuries reveals the technological sophistication the British had stumbled upon. The citizens of the Indus Valley Civilization had mastered advanced urban planning. Their main streets were organized into flawless chessboards, intersecting at exact 90-degree angles. This photograph shows the geometric precision of their civic engineering, notably their comprehensive underground drainage system. Every household connected to a covered main street drain, complete with designated manholes for maintenance. They achieved this through superior material science. While contemporary builders relied heavily on sun-dried mud, the Harappans engineered kiln-daped bricks. This 3D model demonstrates the Harappan principle of universal standardization. Across the entire empire, every single brick was manufactured using the exact same dimensional ratio of 1 to 2 to 4. They resisted water saturation, survived shifting river plains, and endured millennia buried underground. This ancient supremacy and structural integrity provided the exact physical density the British required for crushed stone ballast. The British possessed prior evidence of the site's historical value. In the 1820s, a British explorer named Charles Mason documented these massive ruins, noting the presence of an ancient buried city. Yet, when the railway contractors arrived 30 years later, they evaluated the site strictly as a logistical asset. They bypassed any considerations of heritage preservation in favor of rapid resource extraction. Thousands of laborers were brought in. They ripped out perfectly laid walls, dismantled two-story houses, and tore through the advanced drainage networks, prying the ancient masonry loose with iron pickaxes. The intact 4,500-year-old architectural artifacts were then fed directly into heavy mechanical crushers. The kilned bricks were shattered into jagged fragments to create the necessary friction for track ballast. The volume of the extraction is staggering. The contractors looted millions of bricks, generating enough pulverized material to lay an estimated 100 miles of track bed between Lahore and Multan. The localized pursuit of industrial efficiency effectively industrialized the destruction of a global heritage site. The true cost of this operation remained hidden until the 1920s, when archaeologists Dayaram Sawhney and Rakhaldas Banerjee initiated scientific excavations at Harappa and its sister city, Mohenjo-Daro. Their findings forced a total reassessment of human chronology, proving that India's history extended back an additional 3,000 years beyond the previously accepted timeline. This cross-section of an archaeological mound, known as a tell, shows how sites accumulate vertically. Over centuries, newer construction is built on top of older ruins. Because of this stratigraphy, the most recent and highly evolved chapters of a society sit at the very top. By mining the exposed upper layers of these mounds, railway contractors permanently erased the data detailing the civilization's final, most advanced phase. This photograph shows surviving Harappan seals. Along with the architecture, the extraction likely destroyed artifacts containing the text required to decipher their written language. The extraction effort effectively deleted the climax of the Harappan historical record, replacing the most advanced layers of the city with a bed of gravel. Defenders of colonial rule often emphasize the introduction of modern infrastructure and urban planning to the subcontinent. This wide view highlights the historical irony. Engineers pulverized a society that mastered urban grids and sanitation thousands of years before London existed. The iron tracks of the 19th century rested on pulverized foundations of an older, vanished architecture. The pulverized bricks under the Punjab Railway force us to ask whether the expansion of modern infrastructure inevitably requires the erasure of the past, and what else might currently be buried beneath the path of progress.